we are going to look at the last thing we need to learn about solving systems of equations. This is still elimination. Notice that the two lines are written in standard form, but there's going to have to be an extra step that we didn't have to do when we just simply added the equations together or subtracted them. Okay, so my first equation is x plus y equals -3, and my second equation is 5x minus 2y equals -50. So in the previous lesson, we looked for the variable that had the same coefficient and maybe same signs or different signs. So I have a 1x and a 5x; those aren't the same. And I have a 1y and a -2y; those aren't the same either. So what on earth am I to do? Well, we are going to force the issue. Okay, so what we're going to do, this is called elimination with multiplication. Our goal is to multiply one or both equations by something to make a matching coefficient. So I either want to turn this 1x into a 5x, or I want to turn this 1y into a 2y. Now, there are several ways to do this, and you can get the right answer either way. I like to add, right? I like to add the equations because I make fewer mistakes. And since I like to add, I want to multiply by something that gives me the same number but different signs. Okay? So, how can I multiply and change 1x into 5x? I can multiply by a 5, right? How can I multiply and turn a 1y into 2y? I can multiply by 2. So I already think, well, multiplying by 2 is a little better because it's smaller. And I already noticed that these two signs are different. My y's already have different signs. So here's the trick today to force these two to have a matching coefficient with different signs. I'm going to multiply the first equation by 2. Okay, because I want this 1y to become 2y. This is going to be one great big giant distributive property. I'm going to go 2 times x, that's 2x. I'm going to say 2 times y, that'd be plus 2y. And then don't forget the constant over here. 2 times -3 is -6. You have to multiply every term of the whole equation by the same number. This is basically one of your rules of equations. Whatever you do to one side, you have to do to the other. If I multiply the x and y by 2, I have to multiply the -3 by 2. And then I'm just going to copy the other equation. So now I have 2x plus 2y equals -6 and 5x minus 2y equals -50. And all of a sudden, we're back to the previous lesson. So what I want you to do right now, look at this and tell me which variable we're going to be eliminating. We're going to eliminate the y's, right? Because they match. Am I going to add the two equations or subtract the two equations? I'm going to add because their signs are different. So I want you to take these two equations and I want you to add them and solve for x. I got x was -8. Now, go back to your original equations, and I want you to pick one of the original equations. We could use the new equation because it's equivalent, but it's going to have bigger numbers to deal with. So go back to your original, choose whichever one you like best, and solve for y. I chose the first equation. I substituted -8 in for x, and I got that y was 5. So what is the solution to this system? Where do these two lines intersect? They intersect at the point -8, 5. Okay, so now I have 10x minus 2y equals negative 14, and 2x plus 6y equals 42. And remember, I'm trying to force one of the variables to match. It does not matter which one, so I can do this multiple ways. I know I can multiply 2 by 5 and get 10. I can multiply this 2 by 3 and get 6. So that's, I have to multiply, or I get to multiply by something a little smaller. And I also notice these two already have different signs, right? My y's already have different signs. So I'm going to turn this negative 2 into a negative 6. How do I turn, by multiplication, negative 2 into negative 6? What would I multiply by? I'd multiply by 3, right? So I'm going to multiply this whole equation by 3. So when I multiply this whole equation by 3, you tell me what my new equation is. You should get 30x minus 6y equals negative 42. 3 times 10x is 30x. 3 times negative 2y is negative 6y. And 3 times negative 14 is negative 42. Copy the second equation underneath it. Now I want you to choose or to look and see which variable you're eliminating. Eliminate it and solve for the other variable. My matching coefficients had different signs, so I added, and I got that x was 0. Now, I want you to go back to your original equations, substitute 0 into your favorite one, solve for y, and tell me what you get for that. I chose the bottom equation. When I plugged in x equals 0, I got y is 7. Now, tell me the solution to this system. The solution to this system is the point 0.07. So these two lines intersect at the point 0.07. Now, just out of just a curiosity thing, 0.7 is on the y-axis, right? So these two lines intersect at their they intersect at their y-intercept. If we were to graph these two lines, the y-intercept would be 7 for both of them. That's where they intersect. Next system, 2x minus 5y equals 35, and 4x minus 10y equals 20. So I look at this and I can multiply 2 by 2 to get 4. I can multiply 5 by 2 to get 10. So I'm going to choose 2 either way, but let me show you a little trick here. You know I like to add. I don't want to subtract if I don't have to. And right now, both signs match, right? And I want the signs to be different. So I'm going to multiply the top number, I'm sorry, the top equation by 2, but I want the signs to be different, so I'm going to multiply by negative 2. So you tell me, what is the new equation you get when you multiply the top equation by negative 2? Did you get negative 4x plus 10y equals negative 70? Okay, now I'm going to copy the other equation underneath it. Now I have matching coefficients but different signs, so I get to add. If you did not do the negative here and you had to subtract, that's okay. It's not the end of the world. I just try to force it where I have to add, okay? So I want you to add these two equations and tell me what happens. Did you get something weird? Everything on the left side went away, right? If I'm adding these two equations, negative 4x plus 4x is 0. 10y plus a negative 10y is 0. So everything over here becomes 0. And on the right side, negative 70 plus 20 is negative 50. How often does 0 equal negative 50? Never. So when I get something that can never be true, what is my solution to this system? That's a no solution situation, correct? And since there's no solution, what would happen if I graphed these lines? What would it look like? The lines would be parallel. Very good. The next system says 4x minus 3y equals 13 and 8x minus 6y equals 26. So I either want to make the x match or I want to make the y's match. Looks like I can multiply by 2 for both of them. They already have the same sign, so I'm going to multiply by -2 to get different signs. What happens when I multiply the top equation by -2? Did you get -8x plus 6y equals -26? Okay, write the second one underneath. And now I want you to do your elimination magic and tell me what happens. This time something weird happened, but I got 0 equals 0. What happens when we get something that's always true? What's the answer or the solution to our system? That would be infinitely many solutions, right? So if I were to graph these two equations, what would it look like on the graph? They would be the same line. Notice if I had multiplied by a +2 up here instead of a -2, I would have gotten 8x minus 6y equals 26. I would have gotten the exact same equation. So these are really the same equation. If we were to graph them both on the graph, it'd be the same line. There are infinitely many solutions. Okay, I want to show you one more thing. This would be the most you would have to do to get this to work. So I have the two equations, -2x minus 5y equals 5 and 3x plus 2y equals 9. Notice none of my coefficients match. And notice I can't multiply 2 by anything nice to get 3. I can't multiply this 2 by anything nice to get 5. So on this one, what we have to do is this. We have to multiply both equations. So you look and you get to choose. I have a -2 and a 3. What is something that both -2 and 3 go into? They both go into 6, right? So I could change these both to where they're a 6. What about a 5 and a 2? Well, I could change those both to 10, right? I always like to go with a smaller number. So what would I multiply -2 by, or 2, to get 6? I would have to multiply the top equation by 3. Notice my signs are already different, so I don't have to manipulate the signs. So I'm going to multiply the top equation by 3. You tell me the resulting equation when the top equation is multiplied by 3. I got -6x minus 15y equals 15. Now, what do I multiply 3 by to get 6? I need to multiply by 2, right? So I'm going to multiply the bottom equation by 2. You tell me what my new equation is. I got 6x plus 4y equals 18. So now take these two, eliminate the variable that's ready to eliminate, and solve for the other variable. I got to eliminate the x's by adding, and when I did that, I got y equals -3. So now go back to your original equations. It'll work over here. It's just going to be bigger numbers to deal with. Go back to your original equations, pick your favorite one, and solve for x. I chose the bottom equation because there's no negative signs. I plugged in, I substituted -3 for y, and if I did it correctly, I got x was 5. So what is the solution to this system of equations? The solution is the point 5, -3. If I were to graph these two equations, they would intersect at the point 5, -3.